Hey, it's Sadiya from the Math Center. Today I'm going to be going over a related rates problem with you guys. So the problem I have here says that a spherical snowball with an outer layer of ice melts so that the volume of the snowball is decreasing at a rate of 2 centimeters cubed per minute. How fast is the radius changing when the diameter of the snowball is 10 centimeters? So the first step when we have problems like this is to draw a picture so we can see what's going on. Draw a picture. So the problem states that we have a spherical snowball, so let's just start by drawing a sphere. I'm going to label the radius. The next step is to identify the information that you're given in the problem. So we'll say examine given information. So we see that the volume is decreasing at a rate of 2 centimeters cubed per minute, so that tells us that the rate of change of the volume with respect to time would be negative 2 centimeters cubed per minute because it's decreasing. So we're going to indicate that using dV over dt, so change in volume with respect to change in time equals 2 centimeters cubed per minute. So negative. It also tells us that the diameter of the snowball is 10 centimeters, so I'm going to use a D for diameter. Okay. Step 3. Now we have to figure out what we're looking for in the problem. So what is the problem asking? So it's asking for how fast the radius is changing, so the rate of change of the radius. We're going to use dr dt to indicate that. So that's what we're going to be looking for. Next, we need to find equations that relate the information that we're given to what we're trying to find. So find equations. Okay, so in this problem we have a sphere, we're given the volume, and we want to figure out the change in radius. So we could use the volume of a sphere, so that is V equals 4/3 pi r cubed. And if you were to take the derivative of this, you would get a dv dt term and a dr dt term, which is what we have. So we're going to use this equation. The next step, now we need to take the derivative of this equation that we chose. So we're going to take the derivative of this one with respect to time because we're dealing with rates. So d over dt of both sides, so left and right. So this 4/3 pi term, it's a constant, so we can just take it out of that and multiply it by the derivative of r cubed. So it's gonna become dv over dt equals 4/3 pi, and then the derivative of r cubed with respect to time is 3r squared dr dt. So now that we have this, we need to plug in our information and then we can solve for dr dt. So step 6, plug in given values. Okay, so we said dV dt was -2, so -2 centimeters cubed per minute equals 4/3 pi 3. And then here we have r. We're given the diameter, which is 10 centimeters, and if you remember, radius is half of the diameter, so r equals d divided by 2, which equals 5 centimeters. So we can just plug that in for r. So 3 times 5 centimeters squared, and then dr dt is what we're looking for. So now we have all this, and now we can just solve for dr dt. So step 7 is solve. To do that, we're just gonna divide this whole thing over, and we'll get dr dt by itself. So dr dt would equal -2 5 squared is 25, so 25 centimeters squared. And that simplifies to, well, these 3's cancel, and then you're left with -2 over 25 times 4 is 100. So -2 divided by 100. Our units are centimeters cubed right here, centimeters squared, so it's going to be centimeters per minute. And -2 over 100 equals -1 over 50 centimeters per minute. And that would be the rate of change of your radius, and it's negative, so that indicates that it's decreasing as the volume is decreasing.